Welcome, grade 7s, to an epic educational safari. Today, we're tracking the wild and powerful beast we call energy, and we're going to directly answer every single exam question you need to know. Think of me as your personal safari guide for this explainer. We've got a lot of ground to cover, so grab your binoculars and let's jump right in.
Section 1. Useful and wasted energy.
All right, let's observe energy in its natural habitat, which for us is our everyday appliances. Here is question 1 on our trail. What do systems like appliances, tools, vehicles, and machines provide when we use them? Take a split second to think about it. Got it? They give us a useful energy output. You see, whenever we flip a switch or start an engine, we're basically taming that energy to do a specific helpful job for us.
But, things don't always go perfectly in the wild, which brings us to question 2. What is meant by wasted energy? This is energy that escapes into the environment like a sneaky predator. It does absolutely nothing to help us achieve our goal. It's energy that just slips away during the transfer, totally unhelpful to whatever we're actually trying to get done.
Let's look at a specific specimen with question 3. What is the input and output energy of a typical system like a light bulb? Well, our input is electrical energy, but then it splits. It turns into brilliant light energy, which is exactly what we want, and heat energy, which is our sneaky wasted energy. So one clean input splits into both helpful and unhelpful outputs. Now, to really track this energy, scientists use a very special tool. Question 4 asks, what is a Sankey diagram? Think of a Sankey diagram as a vibrant visual map. It shows us exactly how input energy in a system is transferred, branching off into useful output energy and wasted output energy. It's basically like looking at the glowing footprints that energy leaves behind. Let's move to question 5 and see how this builds our tracking skills. How does the width of the arrows in a Sankey diagram relate to the law of conservation of energy? This is absolutely crucial. The total width of all the output arrows combined, so both the useful and the wasted arrows, must perfectly equal the exact width of the original input arrow. Why? Because in the wild, energy cannot be created or destroyed. It only changes form. So, question 6 asks, how can you see on a Sankey diagram if a system is not very efficient? When you're hunting for inefficiency, you want to look for a massive, wide, wasted energy arrow totally dominating the diagram, while the useful output arrow is just this tiny little sliver. That massive waste arrow, that means the system is doing a terrible job at conserving its energy for the right purpose. Let's track a notoriously bad survivor. Question 7. Describe the energy transfers in a traditional filament light bulb. The input is perfectly good electrical energy, but the output, it only produces a tiny little bit of useful light, and it releases a shockingly huge amount of wasted heat energy straight into the surrounding air. And this leads us right into question 8. Why are traditional filament light bulbs considered to be very inefficient? Honestly, it's simply because they're energy gluttons. They gobble up massive amounts of electricity just to lose most of it as blazing hot, wasted energy. They really aren't well adapted for our modern energy ecosystem.
But thankfully, evolution gives us better options. Question 9. How does a fluorescent light bulb work? Well, instead of heating a wire until it glows, electricity actually zaps through a special gas-filled tube. This causes the gas inside to brilliantly glow and produce visible light. It completely changes the game.
Let's put them head to head for question 10. Why is a fluorescent bulb more efficient than a traditional bulb? The fluorescent bulb smartly conserves energy in its environment. It uses less total energy, it produces way less heat, and it transfers a much higher percentage of that energy into useful light instead of just losing it to the wild. Question 11 asks us to name 2 interesting facts about fluorescent bulbs. Here are their fascinating survival traits. First, they can last up to 10 times longer than a regular bulb. Second, they use about 75% less energy. They are basically the undisputed apex predators of the lighting aisle. Before we leave our household habitat, let's look at one more tool. Question 12 asks for the outputs of an electric drill. The useful output is the spinning, powerful kinetic energy you need to actually drill a hole. But the wasted outputs, that's the loud, screeching sound energy and the heat energy warming up the drill, both of which are just escaping uselessly into the air. Section 2. The National Electricity Grid. All right, now we leave the household behind and set our sights on tracking the magnificent, sprawling beast that powers our entire country.
Question 13 asks, what do we call the electrical system that supplies electricity to all parts of South Africa? Think of it as the giant nervous system of the entire nation. It is the national grid. Now, the national grid needs food to survive. Question 14 asks us to name 5 different sources from which electricity can be generated. The exam might only ask for 5, but I'm so excited about this that we've listed 7 incredible natural sources for you. We can harness coal, oil, gas, nuclear material, falling water, wind, and glorious sunlight. But here is where our safari takes a pretty serious turn. Question 15. How is most electricity currently generated in South Africa, and what is the problem with this source? The harsh reality is, most of our electricity is generated by burning coal. And the severe problem we face is that our supply of coal is dangerously running out. It's a finite resource, and on top of that, burning it has massive harmful impacts on our environment. So what's our plan for survival? Question 16. Which alternative energy sources is the government investing in to generate electricity? Point your binoculars toward the bright horizon, because the answer is wind and solar power. These are renewable sources, meaning they'll never run out on us. Since we do still rely heavily on coal, you absolutely need to know how it works for the exam. Question 17. Explain the 5 steps of how electricity is generated in a coal power station. Step 1. We burn the coal in a furnace for heat. Step 2. That intense heat boils water to create high-pressure steam. Step 3. The rushing steam turns the massive blades of a turbine. Step 4. That spinning turbine turns giant magnets inside a generator to produce electricity. And finally, Step 5. A transformer adjusts the voltage so the electricity can safely travel through power lines right to you. Let's view that same beast through an energy lens. Question 18 tracks the magical metamorphosis of energy inside the power station. First, chemical potential energy changes to heat in the furnace. Second, heat changes to kinetic energy as steam rushes from the furnace to spin the turbine. Third, kinetic energy changes to electrical energy as we move from the turbine to the generator. And finally, electrical energy travels all the way to the consumer, where it changes back into light, sound, and heat in your homes. It's like a giant puzzle coming together. Section 3. Saving electricity at home. For the final leg of our safari, we're returning to our own habitats. Here, we learn how every single one of us can become a warden of the energy ecosystem through conservation. Question 19 asks, give 3 important reasons why we should save electricity. These are absolutely crucial. First, it's expensive. Saving it directly reduces your family's bills. Second, environmental protection. Burning less coal means less harmful gas polluting our air. And third, it prevents load shedding by reducing the extreme pressure on the national grid when too many people use electricity all at once. Question 20 demands action. Name at least 6 practical ways to save electricity in and around the house. Consider this your survival toolkit. Turn off lights when leaving a room. Put a lid on your pots when cooking. Match your small pots to small stoveplates. Hang curtains to trap heat. Turn off appliances at the wall when not in use. Switch to fluorescent bulbs. Use free daylight instead of flipping a switch. And honestly, my favorite, just put on a warm sweater instead of blasting the heater. And here we are, the grand finale, question 21. You need to classify everyday actions into either saving or wasting electricity. Washing full loads, wrapping your geyser in a blanket, and turning the TV off? That is top-tier saving. But using an electric blanket, leaving outside lights on during the middle of the day, or running a half-empty dishwasher, that is terrible wasting. Master these classifications to guarantee you absolutely conquer this exam. As we wrap up our safari, I want to leave you with one final thought. Every single time you flip a switch, you're either protecting our energy ecosystem or you're draining it. So what kind of explorer will you be today? Good luck on your exams, grade 7s. You're going to do great.